Yes, welcome once again to my channel, and today we will start with maths optional paper 1 statics part, sorry, not statics, dynamics part. Okay, dynamics part of maths optional paper 1, we will start it today. Okay, so let's start our discussion. First of all, let's draw a figure over here. The figure looks something like this, that this is your y-axis, this is your x-axis. Okay, and this is your arrow, this is your another arrow, this is your another arrow, this is your one more arrow. Okay, now there is a curve means path of an object, path of an point object. Okay, this is basically path of a point object. This O is your pole. Okay, O is your origin, that is your pole. And from here till here there is a radial vector. Okay, from here till here there is a radial vector. Okay, and this is denoted by your suppose R. Okay, it is radial vector, but one point you should note over here, that we are not going to go into the physics part of it. Okay, the physics portion of it we will not go into that. Okay, so you will have to simply mug up the things, that how to solve this. This is your phi, this angle is called as phi. The angle which this radial vector makes with the x-axis, this particular angle is called as your theta. Okay, this is your phi, and this particular angle is your psi. This is your psi. Okay, this is what, this is your initial line, this is your initial line, this is your y-axis, this is your y-axis, this is your initial line or x-axis you can say. Okay, and this is your point P, which lies on the path of the object. This point P is r comma theta. Okay, its coordinates are r comma theta in polar form. Okay, and from here there is one more line. Okay, let me erase this. There is one more line from here, which is the perpendicular. Okay, so this is your perpendicular from O to this tangent. This is what, this is your curve, right? This is your curve path described by the object. So this is its tangent. This particular line is the tangent. Which line? This particular line is the tangent to the curve. Particular line is tangent to the curve. This is the radial vector towards which the force direction is there. Okay, so this is your radial vector towards which the force direction is there. You must be knowing this, that the direction of a central force is always towards the center. This is a central force. The particle is describing this trajectory under a central force. Okay, so this is the thing. This particular distance, this perpendicular distance of this tangent from this point O is your P. Okay, now there are some points that you should note over here, so that you can and one more point to be noted is that, one more point which you should note is that, suppose this is your y-axis and this is your suppose x-axis. This is another figure. Then this is your origin, O means your pole. Okay, so the thing is that this will be your radial direction, this will be your radial direction, and direction which is just perpendicular to it, this is your transverse direction. So this is what, this is your radial direction. Okay, this is your radial direction. And this is what, this is your transverse direction. Okay, this one. So these two figures you must draw in your notebooks, so that you are comfortable with the upcoming things. So point number 1 which you should note from here is that your psi is equal to theta plus phi. Okay, this is point number 1. Point number 2, which can be read as psi equal to theta plus phi. It should be read like this. Okay, this is phi. Okay. Point number 2 is that your tan phi is equal to your r d theta by dr. Okay, and your this thing, your third point is that I have already told you the meaning of all these terms, all these terminologies. Okay, so the meaning of all these terminologies is very clear to you. Plus 1 by r to the power 4 dr by d theta whole square. Okay, and point number 4, what is the point number 4? Point number 4 is, if u equal to 1 by r, then what will happen? Suppose we define a term, an arbitrary term u, which is defined as 1 by r. So therefore your expression which you wrote on the previous page, this particular expression in the point number 3, it becomes what? It becomes 1 by p square is equal to u square plus du by d theta whole square. Okay, and point number 5, radial velocity. Okay, radial velocity is defined like this. You need not go into the derivations of all this, but these things are very important for you. This single dot represents single derivative with respect to time. Okay, single dot represents single derivative with respect to time. Transverse velocity. Transverse velocity is equal to your r theta dot. Okay, which is basically your r d theta by dt. Okay, these r and these r are same. Okay, I am denoting this type of r and this type of r, both are same. Do not consider them to be different. Okay, sometimes I write like this, sometimes I write like this, sometimes I write like this. Both are same, no difference is there between them. Okay, and one thing you must note before proceeding in this class, that we are not going to go into the detailed physics part of it. Okay, please note over here that we are not going to go into the detailed physics of all this stuff. Because we are preparing for maths optional in this particular class. Okay, so you will have to remember some of the things as it is. Okay, so transverse velocity I have defined. Now we will define radial acceleration. Radial acceleration is equal to r double dot minus r theta dot square. Okay, then it will be your d2r by dt2 minus r d theta by dt whole square. This is your radial acceleration. Okay, this is your radial acceleration. And what is your transverse acceleration? The transverse acceleration is defined something like this, that it is 1 over r d by dt r square. You have to mug up these results. Okay, r square theta dot, that is equal to your 2 r dot theta dot plus r theta double dot, right? When you differentiate this by applying the UV rule, just apply the UV rule over here. Over here apply the UV rule and represent the single derivative by single dot and double derivative by double dot. When you do that thing, over here also it is double dot. Double dot represents double derivative. Differentiation 2 times. Okay, with respect to the same variable. So you have to remember certain facts. So these are the formulas which you have to remember. The proof of all this we learn in physics, but you are here for maths optional, right? So this will be for with regard to maths optional. R theta double dot. Now we will describe what is central force. Okay, we will define central force. Central force is a force which is always directed. Central force is a force which is always directed towards a fixed point. The fixed point is called center of force. Okay, so central force is a force which is always directed towards a fixed point, and the fixed point is called center of force. So we will look at it over here. Okay, we will look at it over here. So suppose you have something of this kind, that your figure looks something like this, suppose. Okay, and this is your O, this is your X. Okay, this is suppose your Y in Cartesian coordinates, and this is your path described by the object. P r comma theta is your coordinates, polar coordinates of the point on this trajectory. Okay, and this is your point P, and from here there is a line. Let me draw properly. From here there is a force towards O. Okay, so this is a force towards O. This F is directed towards O. Okay, this is your center of force. O is what? Center of force. Okay, and yes, all these are the facts. So basically your central force is such a force that the force is always directed towards O. Even if we take some other force which is directed like this, even then that can be taken, its radial component and its transverse component can be taken, and transverse component contributes 0. Only the radial component contributes. Okay, so in that manner you can understand this thing, that why this is always directed towards the line joining the point and the pole, that is center of force. So F is directed towards this center of force O. Okay, so you must have learned the basics of all this in physics, but please note over here that we do not require any physical visualization over here. Okay, so you should be very careful about it. Okay, so please write one note over here. We do not require physical visualization of any physics stuff in this course. Because easy and direct questions are asked from dynamics in maths optional paper 1. Okay, direct questions are asked from dynamics in maths optional paper 1. You must remember this thing very well. Okay, we do not require at all any physical interpretation or any visualization of any physical situation. Okay, all we need is we have to solve all this stuff mechanically. We should know how to solve the mechanically all this stuff. Okay, now central orbit, we will define central orbit. The path described by the particle described by the particle moving under the action of central force is called central orbit. Okay, this is what is your central orbit. Now we will understand. Now this is the orbit described, the path described by the particle. Okay, this is the path which is described by the particle moving under this central force. Under this central force, this is the path described by the particle. So that is called as your central orbit. The path described by the particle moving under the action of central force is called central orbit. Okay, so this is a very straightforward thing. Now we will learn one question over here. We will do one question. Differential equation of central orbit in polar form. We will learn about this. We will learn what? We will learn this. Differential equation of central orbit in polar form. Differential equation of central orbit in polar form. So let us understand this. Now your question, okay, write over here one question based on this. Okay, write one question. Establish the formula based on this only. The question is based on this. Okay, question is based on this. Question is based on this. Establish the formula. Establish the formula d2u by d theta 2 plus u is equal to f divided by h square u square. Okay, your theta dot is what? Theta dot is your h u square. Okay, where u is equal to your 1 by r for the motion of a particle for the motion of a particle describing a central orbit under an attraction F, okay, per unit mass. So we will do this question now. Okay, we will do this question. What does the question say? You have to establish basically this particular formula. You have to establish this particular formula. Okay, where the value of theta has also been given to you. Value of theta dot has also been given to you. Okay, where u is your 1 by r, which you already know by definition. We represent u by 1 by r everywhere over here. Okay, for the motion of a particle describing a circular orbit under an attraction F per unit mass. Okay, so we will solve this now. Okay, so we will solve this. So let's start this question. First of all, we will draw the figure. First of all, what we will do? First of all, we will draw the figure, proper figure for it. Okay, this is your orbit of the, this is your orbit described by the particle, and your dicto same figure which you had already drawn some time ago. Same figure will be repeated everywhere. P r comma theta. Okay, this is what? This is your from here till here. From here, this is your point O. Okay, from here till here, what is there? This is your radial vector. From here till here, this is your what? Radial vector. Okay, and this is your F force per unit mass. Okay, and this is your tangent to this particular curve. Where is the tangent? This is your particularly, this is your tangent. Okay, let me draw properly. Let me draw it. First of all, let's make the curve little bit like this so that I can draw it properly. Okay, yes, this is your tangent. Okay, so this is your what? This is your theta as already described. This is your phi. This angle is your phi, and this is your psi. Okay, this is your psi. This is what? This is your perpendicular, which this particular is your perpendicular. Okay, from here till here, the line which you draw, this is your perpendicular P from O to this tangent. Okay, this is your 90 degree. This is your perpendicular. Okay, so this is the figure which you have drawn, and this is your trajectory of the particle, this particular. Okay, hopefully you are able to see this. And over here, this is your y-axis as always. This is what? This is your y-axis as always, and this particular is your x-axis as always. This is also called as your initial line. This is also called as your initial line. Okay, so let's start our answer. Okay, yes, so let's once again start it. Okay, so suppose a particle, this is your figure which you must have drawn in your notebooks. Okay, so suppose a particle, now write all this stuff over here. Okay, suppose a particle moving in a plane curve. Particle moving in a plane curve means planar curve. Okay, in a planar curve under an acceleration, means if we draw the curve like this, then it will lie in the mobile screen. This curve will lie in the mobile screen. It will not be something of this kind. Okay, it will not be something of this kind, that this part is out of the plane and this particular part is below the plane. Non-planar curve is not there. Okay, and one more example of a non-planar curve is that suppose you have a curve like this. Okay, suppose you have a curve like this. This is your out of the plane. Clearly this is your below the plane, and this is your out of the plane. Okay, and this is your on the plane, this particular part. So this is non-planar curve. So such type of curve is not there. Okay, a planar curve is there. So suppose a particle moving in a planar curve under an acceleration, that is force per unit mass, F, which is always directed towards a fixed point O. Towards a fixed point O. So you have understood the meaning of this already. This is by the definition of central force, right? Suppose a particle moving in a planar curve, you can see over here. Suppose a particle moving in a planar curve, okay, under an acceleration, force per unit mass F. Okay, over here you can see over an acceleration F, which is force per unit mass. It is directed towards this point O. Now this F is not force over here. Okay, write one note over here. Please note that F is not force over here. Unlike physics, where F is a force, instead F is general representation of force per unit mass in this paper of dynamics. Okay, so it is the general expression for force per unit mass in this dynamics paper. Okay, so it is force per unit mass, that is it. In other words, it is acceleration. In other words, it is acceleration. Let me write properly here. In other words, it is acceleration in this okay. So you have to remember this thing. So let's erase this. So towards a fixed point O. Okay, let OX be the initial line. Okay, towards a fixed point O, let your OX be the initial line, be the initial line. Let P r comma theta be the position of the particle at any time t. Let P r comma theta with the position of the particle at any point p at any time t. Okay, this is the position of the particle at any time t, which has been already shown to you over here. This is the position of the particle at any time t. Okay, at any time t, since the acceleration, since the acceleration which is directed towards the fixed point, acceleration is directed towards the fixed point O, right? Because it is under a central force, so acceleration will be directed towards a fixed point O. So therefore the particle has only radial component of acceleration. This is quite obvious. Therefore the particle has only radial. I already told you this. Has only radial component of acceleration. Okay, only radial component of acceleration towards the point O. Okay, so the particle will have only radial component of acceleration towards the point O. The particle will have only radial component of acceleration, because the transverse component, if suppose there is a force acting like this, okay, then that force can also be transformed into radial component and transverse component, and the transverse component will have zero effect over here. So only radial component remains. So only this component will remain. Okay. So the only radial component of acceleration towards the point O. Therefore, what will happen? Therefore, the equation of motion along radial and transverse direction are radial and transverse direction radial and transverse direction are your by the formula which we have already derived. Okay, so therefore equation of motion along radial and transverse direction are as follows. You already know that equation of motion in central force is like this. Okay, I have already made it right. You must have written in your notebooks by now. This is your equation number 1 and this is your equation number 2. Like we have the Newton's equations, right? V square minus u square is equal to 2s. Okay, s is equal to ut plus half at square, v is equal to u plus at. All those things we have in kinematics, right? You must have learned at the time of JEE in your physics. So the same way, in the similar fashion, these are the equation of motion. These are what? These are basically your equation of motion as seen over here. Therefore the equation of motion along radial and transverse direction. These are what? The equation of motion in radial and transverse direction, which I have already written in the previous slides. You must have copied down in your notebooks. Where I had written? Over here I had already written. See over here. See over here. I had already written all this equation of motion. Okay. These. Okay. So these are your equation number 1 and 2. Integrate equation 2. Now we will integrate equation number 2. Why we will integrate equation number 2? This is very clear from the question. From the question this is very clear. Where is the question? Over here. It is the question is over here. Theta dot is equal to hu square. Now we need to find out the value of theta dot. Okay, we have to find out the value of theta dot. So we will first of all integrate this. See over here. Okay. So let's see. Integrate equation 2. Now equation 2 is something like this. d by dt r square theta dot is equal to 0, which is your equation 2, which I have already written. Integrate equation 2. Integrate equation 2. Let's integrate this. Then what will happen? Clearly, if we try to integrate this, then it will look something like this. 1 over r d by dt r square theta dot is equal to integration 0. Okay. So we will integrate with respect to time. Okay. So it will look like this. Plus c. Okay. So after we integrate this, clearly this is a variable t. So 1 by r will be a constant. Okay. And the integration of this thing will be your r square theta dot. So what do you get after integration with respect to 2? You get r square with respect to 2, not 2, with respect to t. Okay, after integration with respect to t, you get something like this, constant, which is equal to your h, say. Okay, from 2 you can clearly see this thing, that whenever the differentiation is 0 of a particular quantity, then that particular quantity is constant. So this particular quantity must be a constant over here, right? So that particular quantity is your constant. From equation 3, what happens from equation 3, which we have written above? Theta dot value you get as h by r square, okay, and 1 by r square is equal to your what? 1 by r square is equal to your u square, right? So your theta dot becomes h u square. Why? Because your u is defined like this. U is defined as 1 over r, right? This is suppose your equation number 4. Okay. Now r dot. Now r dot is what? By the definition of dot, it is single differentiation. Okay. So we can write it like this, as we have to bring all the terms in we have all these terms in all these terms are in terms of differentiation of t. Okay, these are in terms of what? Differentiation. These are in terms of differentiation with respect to t. Okay, these are in terms of differentiation with respect to t. But in the question there is differentiation with respect to theta. In the question where there is differentiation with respect to theta, you can see over here. In the question there is differentiation with respect to theta. So we have to eliminate t. Okay. So r dot, the value of r dot is dr by dt. So we will now write it in terms of differentiation with respect to theta. So it will look something of this kind, which is over here, d theta by dt. Okay, then what is your dr by d theta? Your dr by d theta will be your minus 1 by u square du by d theta. How? And d theta by dt has already been given to you, which is your h by r square. So how this particular step has come? How this particular value has come? Okay, this particular value, how it has come? You can see this clearly. I am writing on the next page. Okay, let's write the explanation in the bracket. Let's write the explanation in the bracket, that as your r equal to 1 by u, so that implies that your dr by d theta will be equal to minus 1 by u square du by d theta by the differentiation definition, right? And your d theta by dt is what? It is your theta dot, right? This particular thing is your theta dot, and theta dot has been given as h by r square. So you will put this value. Okay, so after you put all those values, what do you get? So clearly this is the final steps which we have written. So your r dot value will be equal to minus h du, let's write properly, minus h du by d theta. How? Clearly see, this is your minus, this thing will turn out to be 1. U square multiplied by r square will turn out to be 1, because u equal to 1 by r. So this product will turn out to be 1. Okay, so I must write one bracket also over here, so that you are not confused. Okay, so this and this will turn out to be 1. This thing and this thing will turn out to be your 1. Okay, so that's why minus h by, what is the final thing you got? r dot is equal to minus h du by d theta. Okay, now you will find out similarly r double dot. Why are we finding r double dot? What is our line of thinking? Why are we finding r double dot? Because over here in this, now we have converted the r dot. We have converted r dot in terms of theta. We have converted r dot in terms of theta, and in the question we have been given. In the question we have been given everything in terms of theta. Question we have been given everything in terms of theta, and we have equation of motion which are in terms of dt. Okay, not with respect to theta, we have with respect to t. So we converted this in terms of with respect to theta. Now there is r double dot in our equation of motion. We have theta dot also, and we have r double dot also in our equation of motion, which are equation 1 and 2. So we will also find out the value of r double dot. This is our line of thinking, so that we convert everything in terms of with respect to differentiation with respect to theta. We convert everything with respect to theta. Okay, so r dot value is like this. Now r dot value is like this. So now r double dot. Okay, now r double dot will be what? d2r by dt2. This is your r double dot, which will be in turn equal to d by dt dr by dt. Okay, and dr by dt value which we have already got. What is the dr by dt value? This is the dr by dt value which we got in terms of theta, differentiation in terms of theta. So we will substitute that value over here. So after we substitute that value over here, what do we get? What do we get? We get d by dt. What is the value of dr by dt? Dr by dt is h du by d theta. Okay, minus h du by d theta. So minus h, as it is a constant, so it will come out of the differentiation. Minus h, as it is a constant, it will come out. And what do you get finally? d by dt. Okay, d by dt of du by d theta. Don't you get this? You get this, right? Then again, we are, as we want everything in terms of theta only, so we will again do mathematical manipulation over here. What is our previous step? It is like this, right? So we will again write it like this: d by dt d theta. Again we will apply chain rule, basically. Okay, chain rule of differentiation. So it will turn out to be okay. Now minus h, what will this be equal to? This will be equal to your d2u by d theta 2, right? And d theta by dt has already been given to you in the question. D theta by dt has already been given to you in the question. What is its value? D theta by dt means theta dot, which has already been given in the question. Where is theta dot? This is given to you in the question. Okay, so theta dot value we substituted hu square. Okay, so finally what do you get the value of and this is all r double dot. Okay, this is all r double dot. Okay, so what do you get finally? Finally you get the value of r double dot. What will it be equal to? It will be basically your r double dot is equal to minus h square u square d2u by d theta 2, right? This is your equation number 5. Okay, now we have equation number 1, 4 and 5 with us. What is equation number 1? Equation number 1 is your like this. This is what? This is your equation number 1. This is your equation 1, which we have already written previously. What is your equation number 4, which has been given in the question? Which has been given in the question. Okay, this is your equation 4. And what is your equation 5? This is your equation 5. So from equation 1, 4 and 5, from equation 1, 4 and 5, what do we get? We get something of this kind. From equation 1, 4 and 5, we get something of this kind. Minus h square u square d2 u by d theta 2 minus 1 over u h u square whole square is equal to minus f. How did we get this? How did we get this? Put the value of r double dot from here. See, put the value of r double dot from here over here, and put the value of theta dot from here over here. This is how you will get. Okay. So from equation 1, 4 and 5 you got like this, right? And finally what do you get? Finally you get, let me write once again, h square u square d2u by d theta 2. Okay, plus minus 1 by u h u square whole square is equal to your minus f, and that implies h square u square d2u by d theta 2 plus h cube, no, not h cube, h square u cube. Okay, because u to the power 4 will come from here and 1 u will be cancelled. Okay, and the minus sign is also gone, so you get something like this. Okay, minus sign has been reduced, means removed from both the sides, cancelled from both the sides. So what do you get finally? Finally the last step which you got was like this, d2 u by d theta 2 plus h square u cube is equal to your f. So you will divide by h square u square on both the sides. So after you divide by h square u square on both the sides, you get thus u is equal to f divided by h square u square. Okay, which is the required differential equation of central orbit. This is your what? This just put this in square. This result you have to remember. Okay, this result you have to remember. This is your result which you got. Now you write over here, which is the required differential equation of central orbit in polar form. In polar form. Okay. Now this is the differential equation of central orbit in polar form. Now we will do the same thing in pedal form. Okay. Now we will write question. We will write differential we will derive it. Differential equation. Okay, differential, write properly, differential equation of central orbit in pedal form. Okay, so let's start. Let P be what? Well, now how does the equation of central orbit in pedal form look like? Okay, so your pedal form equation looks something like this. Okay, so let's write over here your pedal form equation. Okay, your pedal form equation looks something like this. It looks like this: h square by dq dp by dr is equal to your f. This is how the pedal form equation looks like. Okay, this is how the pedal form equation looks like. Okay, now in pedal form, so let's start. Let P be the length of perpendicular. Let P be the length of perpendicular from O on the tangent at P r comma theta. The same thing, we have already drawn this. You must have noticed where we have drawn. Have a look over here. This is the thing which we have drawn. This P, length of perpendicular from O, that is your pole, that is your center of force. This is your length of perpendicular from center of force on this particular tangent to this curve. This is what? This is your tangent, and this is the perpendicular to the tangent from the pole. Okay. So let P be the length of perpendicular from O on the tangent at P r comma theta. The point P has polar coordinates r comma theta. Then from the basic equations, what do you have from the basic equations? Then, okay, let's write properly. Then what do you have? Then P is equal to your r sin theta, r sin phi basically. Okay, this is your equation number 1. And tan phi is what? Tan phi is equal to your r d theta by dr. Right? This is your equation number 2. And how is the triangle drawn? How is the triangle drawn? This is the triangle drawn. This is the triangle RP. This is your phi. Now how we have drawn this? Okay. In order to see this, you will have to go into this figure. Just take this figure out of here. Okay, this particular figure, just take it out. Let me mark it properly. This particular figure, okay, this particular triangle, okay, this particular triangle, just put it outside, separate it from the figure. If you separate that particular thing from the figure, then you will get something of this kind. Okay, this triangle you will get. So then P is equal to R sin phi. How? P is equal to R sin phi. How? By definition of sin theta. By definition of sin phi, you will have P equal to R sin phi. And how do you get tan phi? How do you get tan phi? How do you get tan phi? Let's see over here. Tan phi, it will be equal to P. This is suppose your x. So then it will be your P by x. Okay. This is your tan phi. Now you know this very well that this x will be your what? This x will be what? This x will be P square root of R square minus P square. Okay. Square root of R square minus P square by Pythagoras theorem. Okay. And d theta by dr. Now we have something called as theta. We have theta also over here. Let's see. We have theta also. Okay. So the value of theta, now tan phi value, already it has been given to you in the beginning of the class. It has been given to you. Tan phi value has already been given to you in the beginning of the class. R d theta by dr. Tan phi is what? R d theta by dr. Okay, it has already been given to you in the beginning of the class. So we need not go into the derivation of that. We will directly write this. Just forget this. Okay. Just forget all this. Let's not go into the derivation of that. Okay. So as already been told to you, this equation 2 has already been told to you. R d theta by dr. This equation 2 has already been taught to you. Where? Have a look at the beginning. Over here it's there, right? R d theta by dr. So you have R d theta by dr. This is your equation number 2. Now from equation 1, what we will do? We need the equation in pedal form, and in pedal form we have, how does the pedal form equation look like? We have to derive the pedal form. Okay, just have a look over here. Just have a look over here. Just a second. Okay. Okay, in pedal form, how does the equation look like? We have to derive this. We have to derive h square divided by p cube multiplied by dp by dr is equal to your f. We have to derive this. So over here clearly there is 1 over p. 1 upon p is there. So in the equation which we have p. Okay, we have p in this equation, and we want 1 upon p, and we want dp by dr also, right? So we will differentiate also, and we will take 1 upon also. So just this equation 1, notice this equation 1, we are going to do some manipulations. Okay, so from equation 1, let's write from 1. One over p square is equal to 1 over r square. Why did we do this? Why did we do this? Why did we do this? Because in pedal form we have the expression in our mind. This is the pedal form equation which we have in our mind, and in this pedal form equation dp by dr is visible, means we will have to differentiate p with respect to r, and 1 over p cube is visible. So we will have to basically take the reciprocal of equation 1, and as soon as you take the reciprocal of this equation 1, this particular equation 1, when you take the reciprocal, okay, when you take the reciprocal of this, what do you get? You get something like this. The sine square phi will become cosec square phi. After you square, first take the reciprocal and then square. Okay, so I will write over here, take reciprocal, taking reciprocal and then squaring on both sides. First of all, we will take the reciprocal and then we will square on both sides. So this is the thing which you get. So this is from your equation 1. Okay. Now we will write it once again, so that we have a conveniency with us. This is the expression which we got. Now cosec square phi can be written as 1 plus cot square phi. So 1 over p square is equal to 1 over r square 1 plus cot square phi. Okay. Now cot phi is what? We already have the tan phi value with us. We already have tan phi value with us, which is there in the equation 2. So we will just substitute that value of cot. Okay, 1 upon 10 is cot. 1 upon 10 is equal to your cot. So 1 upon 10 is your cot. So 1 by r dr by d theta square. Okay, this is the thing which you get. How did you get this? You have tan phi value, so you took the reciprocal. Okay, so this is the thing. Then after you take the reciprocal and multiply, then further step which you get, what do you get further? The further step which you will get is 1 over p square is equal to 1 over r square. Okay, 1 over, write properly here, 1 over r square 1 plus 1 over r square dr by d theta whole square. Right? You will get this. Then what do you get? 1 over p square is equal to, just take this inside, open the bracket, 1 over r square plus 1 over r power 4. What do you get? dr by d theta square. Right? Let us assume this to be your equation number 3. Okay. Now we will convert it in terms of u. Convert this in terms of u. Why are we converting it in terms of u? Why are we converting it in terms of u? Because we have our equation of motion, right? We have our equation of motions in terms of u instead of r. Our equation of motions which we have already discussed in the beginning of the class. The equation of motions which we have discussed in the beginning of the class, those are in terms of u, and over here everything is in terms of r. So we will make the substitution of u equal to 1 by r. We will make this substitution. Okay. So let's write properly. the equation 3 which you got is like this. The equation 3 which you got is this: 1 over p square is equal to 1 over r square plus 1 over r power 4 dr by d theta whole square. Now this is your equation 3. Let u is equal to u or 1 by r. That implies r is equal to your 1 by u. Okay, so we will get the value of dr by d theta from here. What will it be equal to? Minus 1 by u square du by d theta, right? So just substitute this value of dr by d theta in this equation number 3. Okay, so when you substitute that value in equation number 3, so what do you get? Therefore you get 1 over p square. The equation 3 you have is like this. The equation 3 which you have with you is like this. This is your equation 3, and value of dr by d theta which you got is equal to what? Dr by d theta has come out to be right. Now put this value in this. Okay, so what do you get after putting that value? Therefore we will get 1 over p square is equal to u square plus u power 4 minus 1 by u square du by d theta whole square. Okay, this is the thing which you get. Now again, therefore that implies that 1 over p square is equal to u square. This u power 4 and u power 4 will cancel out. So what do you get? Du by d theta whole square. This is the thing which you get. This is suppose your what? Equation number 4 suppose. Now differentiate equation 4 with respect to t. Differentiate. This is what? This is your equation number 4, right? So differentiate equation 4 with respect to your t. Okay, so as soon as you differentiate this equation 4 with respect to t, what do you get? Minus 2 e to the power minus 3 dp by dr, okay, is equal to 2u du by dr plus 2 du by d theta multiplied by d by dr du by d theta. This is the thing which you will get. Okay, then again what will you do? Minus 2 by p cube dp by dr. Okay, then you get 2u du by d theta by dr plus 2 du by d theta dot d by d theta du by d theta by dr by chain rule of differentiation, right? From here you got this. Okay, you got this, and then you will apply the chain rule of differentiation again. Okay, so after you apply the chain rule of differentiation to that thing, this is the thing which you get from here. Okay, then what will happen? The next step is, let me first check it whether it is correct or not. Yes, it is correct. Okay, then in the next step, that implies minus 2 by p cube dp by dr, that will be equal to your u plus d2u by d theta 2. You must check all the steps after going home. Du by d theta dot d theta by dr. Okay, so what happens is that from here minus 2 by p cube dp by dr, okay, is equal to your what? F by h square u square times 2 du by dr. Now how did you get this? How did you get this? From here till here you must be knowing that u plus d2u by d theta 2. Just check back, check the previous steps. Okay, where we have written, see this formula, this is what in polar form, right? So this thing we are going to use. Now this thing we are going to use over here. Okay, so this thing you have, in place of this you wrote this. Okay, now so from here you wrote this. Now du by dr, what will happen to du by dr? You can further simplify this. Okay, you can further simplify this. So your this thing will become minus 2 by p cube dp by dr is equal to your f divided by h square u square. And what do you have over here? 2 du by dr you have. Okay, so instead of 2 du by dr we will have minus 1 by r square, because u equal to 1 by r. Okay, so write the explanation over here as u equal to 1 by r. So that implies that your du by dr will be equal to your minus 1 by r square. So you substituted that thing. Okay, so instead of du by dr over here we substituted this whole thing. So what did you get finally? So what do you get? You got h square by p cube dp by dr is equal to your f. This is the thing which you got in the final step. Okay, this is the thing which you got finally. So you can write over here, how did you get this? You can clearly see this thing, minus 2 and minus 2 will cancel from here. Okay, and finally this h square will go over here. Okay, then everything is there. Okay, so this is the thing which you will get. this u square and r square will yield you 1. Okay, so this is the final equation which you will get from there. Now write over here, this is the required equation. Above equation is the required differential equation of central orbit in pedal differential equation of central orbit in pedal form. And while deriving this pedal form, we have already also used the polar form. Okay, while deriving this pedal form, we have already used the polar form also. Okay, now or the or method. Okay, you can do it like this also. We have with us, this is our alternate solution. Okay, just write over here, this is our alternate solution. This is our alternate solution. So our alternate solution, how does it look? We have with us 1 over p square equal to u square plus du by d theta whole square. This we have with us, right? Now differentiate this with respect to theta. Differentiate with respect to theta. So what do you get? After differentiating with respect to theta, you will get like this. Okay, you will get something like this. Okay, how did you get this? By applying the product rule. Okay, not applying the product rule. You can clearly see this thing from when you differentiate with respect to theta, 2 will come forward. Okay, this, see na, this particular 2 will come forward, 2 minus 1 will happen, then du by d theta will occur. Okay, so it is a common sense. Okay, it is a common sense. So what did you get from here? That implies the thing which we have got with us is this. Is equal to 2u du by d theta. This is the step which I am writing again so that I am able to differentiate it and integrate it. d2u by d theta. So then the next step, du by d theta, just put it common. Put this du by d theta common. Du by d theta, take it common. And 2 also take it common. Du by d theta, take it common. 2 also take it common. Okay. So after taking those two things out common in the bracket, dp by d theta is equal to your 2 du by d theta u plus d2u by d theta. Got it? This is the thing which you got. Then u plus d2u by d theta 2, you already know what is the value of this. From polar form you know the value of this. Okay, so just substitute f by h square by u square over there. Okay, so that implies that your this particular thing will become what? Minus 2 p to the power minus 3 dp by d theta is equal to 2 times du by d theta f by h square by u square multiplied by f by h square u square. Okay, so how did you get this? This is you got by is equal to f divided by h square u square. Okay, now du by d theta, what is the value of du by d theta? 1 minus 1 by r square. You know this very well, that u is equal to your 1 by r, right? So your du by d theta will be equal to d by d theta 1 by r. Okay, that will be equal to in turn d by dr 1 by r into d just a second dr by d theta. So what will this be equal to? Minus 1 by r square, minus 1 by r square dr by d theta, right? So put this value of du by d theta over here. Okay, put this value of du by d theta over here. So what do you get? What do you get? Minus 2 p to the power minus 3 dp by d theta minus 2 p to the power minus 3 dp by d theta, okay, is equal to 2 times du by d theta is what? This is the value of it, 1 minus 1 by r square dr by d theta. Okay, dr by d theta. So I put its value over there, multiplied by f by h square u square divided by h square u square. Okay, so this is the thing which you got. So that implies what? Minus 2 p to the power minus 3 dp by dr into dr by d theta is equal to minus 2 by r square dr by d theta f divided by h square u square. Now this is the thing which you got. You just applied chain rule over here. Okay, so you applied chain rule. So what happened? This minus 2 and minus 2 cancelled out. Okay, so finally what did you get? From here you get p to the power minus 3 dp by dr okay, into dr by d theta is equal to one by r square dr by d theta f by h square u square f by h square. So this and this will cancel out. So what did you get? e to the power minus 3 dp by dr is equal to 1 over r square f by h square u square. This and this will cancel out. So again you get f by h square. Okay. Then we will rewrite this expression in suitable form. So as soon as you rewrite this h square, when you write it over here on the left hand side, so this h square when you bring it to the left hand side, and p to the power minus 3 when you bring it to the right hand side, so it will become h square divided by p cube dp by dr is equal to your f. Okay, h square will go over here. You can see this thing. This h square will go over here. Okay, over here. This p cube, it is in the denominator, it will go in the numerator over here, and this will remain as it is. Okay. So you get like this. This is your equation in pedal form. Okay. This is your pedal form. Now let's move on towards our next problem. Okay. Let's move on. Question number, your question. A particle describes an equiangular spiral r is equal to a e to the power theta cot alpha under the force F to the pole. Find the law of force. Find the law of, just a second guys, find the law of force. Okay, find the law of force. So particles described an equiangular spiral, all these do not have any meaning. You can just ignore all these things, equiangular spiral and falana dhimkana, everything will be written over there. That particle described like this, particle described like that, it doesn't matter. As far as it is concerned, if it is central force, then it doesn't matter whether it is equiangular spiral or any other figure. As long as it is your central force, it doesn't matter whether it is equiangular spiral or not, or whether it is some other figure. Okay, so your equation of your particle is given like this, and under a force F to the pole, so you have to find out what law of force. You have to find out basically law of force. Okay, so what does it mean by law of force? Law of force means that you have to find out the relationship between F and R. Okay, you have to find out the relationship between F and R. So I will write over here, just note it down. Okay, note law of force means that you have to derive relationship between the force and R. You have to derive the relationship between force and R. That's the meaning of law of force. So you must remember this thing. Find the law of force. So what is given to us? The things which is given is R is equal to A e to the power theta cot alpha. Theta cot alpha. That implies what is your U? U is equal to your 1 over A e to the power minus theta cot alpha, where U is equal to your 1 by R, right? You took the reciprocal, that's it. U is equal to your 1 by R. So you took the reciprocal on both the sides. As soon as you take the reciprocal on both the sides, A will become 1 by A and power will become negative in sign. Okay. So this is suppose your equation number 1. Now therefore du by d theta is equal to what? Therefore your du by d theta will become, when you differentiate with respect to theta, what will happen? 1 upon A outside as it is, e to the power minus theta cot alpha as it is, and d by multiplied by what will come? d by d theta minus theta cot alpha will come, right? So this will in turn become minus 1 by A cot alpha e to the power minus theta cot alpha. It will become like this, right? Minus 1 by cot alpha e to the power minus theta cot alpha it will become. So du by d theta is equal to minus u cot alpha. How minus u cot alpha? Because u value you have already found out. The value of u is like this. Now look at this carefully. Okay, this whole thing, this thing plus this thing in multiplication, just bring them together. After you bring them together, it is equal to minus u. Look at it carefully. It is equal to your minus u. So minus u will come. So minus u cot alpha will come. So du by d theta will become your what? Du by d theta has become, that implies your du by d theta has come out to be equal to minus u cot alpha. So that implies your d2 u by d theta 2. How its value will be there? Its value will be again d by d theta of this thing. So what will it be equal to? Minus cot alpha, as it is a constant, it will come out, and du by d theta will remain, because alpha is a constant over here, right? Alpha is a constant over here. Now du by d theta, you already know the value of du by d theta. The value of du by d theta you know from here. Just substitute it over here. So as soon as you substitute that value over here, what do you get? You will get something like this: d2u by d theta 2, d2u by d theta 2. So in the place of du by d theta, substitute this. So it is equal to minus cot alpha multiplied by du by d theta. In place of du by d theta, you will get minus u cot alpha. So what did you get finally? U cot square alpha. So d2u by d theta 2 is equal to u cot square alpha. Now we know that we know that the differential equation of central orbit is what? It is your d2u by d theta 2 plus u is equal to your f divided by h square u square. So d2u by d theta 2, its value you will substitute over here. So what do you get? You substituted basically u cot square alpha plus u is equal to f divided by h square u square. You got this? Okay, so let's further write this to be equal to what? Just bring this to the left hand side, bring the RHS to the LHS and LHS to the RHS. Just interchange and write. So after you interchange and write it, it becomes f by h square u square is equal to your u plus u cot square alpha, which is equal to u to 1 plus cot square alpha. Okay, which is equal to u cosec square alpha. Okay, now after you write this, you will bring this h square u square to the RHS, this h square u square to the RHS. So as soon as you bring it to the RHS, what does it become? Your value of f from here the value of f will come out to be h square u cube cosec square, h square u cube cosec square alpha, h square u cube cosec square alpha. This is the value of f. Now that implies that your u is equal to what? U is equal to 1 by r, right? So you can write this to be h square divided by r cube cosec square alpha. Okay. Now you got the relation between f and r now. So f is equal to your 1 by r cube, and this will become h cosec alpha whole square, right? Now mu is equal to h cosec alpha whole square. Okay, now let us consider, this is a constant, right? This whole term over here, this whole term, it is a constant, right? Because h is a constant, alpha is also a constant, so it will be a constant. Now what do you get finally? That implies that your f is equal to mu into 1 by r cube, where this mu is equal to h cosec alpha whole square. Okay, so that implies that your f is inversely proportional to 1 by r cube, because this is a constant, right? H cosec alpha whole square, this is a constant, so f is inversely proportional to 1 by r cube. So you got this. So this is the law of force. So that is force is inversely proportional to third power of the distance from the pole, of the distance from the pole. Force is inversely proportional to third power of the distance from the pole. Okay, so this is how you can write this thing. So this is the required law of force. This is the R is what? R is distance from the pole, distance of the point P from the pole. R is what? You must have seen here, right? R is what by it? Let's see over here. R is what? Distance from the pole, right? Distance from the pole. This point P from the pole. Distance of point P from the pole. Third power of the distance. This is the required. This is the required law of force. This is the required law of force. Okay, this is the required law of force. Now we will look at the next part in the next class. Okay, next class means this class only. Let me have some water, then I will return. Yes, let's move on towards a similar problem. Okay, a similar problem, very similar to this one. We have to again find out the law of force. So question: a particle describes the curve r power n is equal to a power n cos n theta. Okay, under a force F to the pole. Under a force F to the pole. This is basically your capital F. Capital F. Okay, to the pole. Find the law of force. Find the law of force. A particle describes a curve given like this under a force F to the pole. We have to find out the law of force. Okay, so how can we find out this? Let's see one by one. Okay, and write one more thing over here. Okay, write one more thing. Also evaluate. R square is equal to a square cos 2 theta. You have to evaluate for this. Over here n equal to 2. Okay, similarly you have to evaluate this. R power 4 a to the power 4 cos 4 theta. Your n is equal to over here 4. Okay, if you substitute the value of n over here, n equal to 4, n equal to 2 over here in the red bracket, you must see this in the red box, okay, which has been underlined as red. So over there you must have seen this, that when we substitute these values of n, we will get this, and r equal to a cos theta, that is n equal to 1. Okay, so third is law of force for these things. R equal to a cos theta, which is n equal to 1, and this case corresponds to what? This case corresponds to a particle. n equal to 1 corresponds to what? A particle describing describes a circle pole on its circumference, pole on its circumference under a force P to the force. Under a force P to the pole. Find law of force. You must have learned this in your lower classes, that whenever in under central force, whenever a circle is described in central force, you get r equal to a cos theta type of equation. Okay, find the law of force. So let's solve this step by step. Okay, let's solve this. We have been given what we have been given. Given. So solution over here. Given is r power n equal to a power n cos n theta. That implies r equal to 1 by u. So 1 by u to the power n equal to a power n cos n theta. Okay, because your u is equal to 1 by r, you already know this, right? As already told to you. So from here one thing you can get, that this is basically a power n u power n cos n theta. Okay, so that implies what? That implies a power n u power n cos n theta is equal to your 1. Let this be your equation number A. Now take the log on both the sides. Take logarithm, taking logarithm on both the sides. After you take log on both the sides, what do you get? What do you get after you take the log on both sides? N log A plus n log u plus log cos n theta is equal to log 1 is equal to 0. This is the thing which you get. Log n log a, n plus n log u plus log cos n theta is equal to log 1 is equal to 0. Okay, after you apply all those laws of logarithm, then you get n log a plus n log u plus log cos n theta is equal to your 0. This is basically your equation number 1. Differentiate equation 1 with respect to theta. Okay, differentiate equation 1 with respect to theta. With respect to theta, what do you get after you do that? What do you get after you do that? Therefore, your n into 1 by u du by d theta. Okay, you differentiated with respect to theta, right? So you will get like this, plus 1 over cos n theta minus n sin theta is equal to your 0. Okay, that implies 1 over u du by d theta is equal to tan n theta. Okay, that implies your du by d theta is equal to u tan n theta. Okay, again differentiate with respect to theta. Again differentiate with respect to theta. What do you get? d2u by d theta 2 is equal to du by d theta tan n theta plus u sec square n theta into n. Okay, so when you differentiate this thing with respect to theta once again, so you get something of this kind. Then what happens? Then d2u by d theta 2 is equal to, just rearrange the terms. Okay, just rearrange the terms. In the place of this du by d theta, substitute this thing in the place of du by d theta. So what do you get? You get d2u by d theta 2, d2u by d theta 2, that will be equal to, in turn, what? Du by d theta. What is the value of du by d theta? U tan n theta. So equal to u tan n theta. Okay, u tan n theta. Then tan n theta multiplied by tan n theta. Then what do you get? U sec square n theta n plus n u sec square n theta. Okay, u n sec square n theta. ठीक है ना? So what do you get from here? That implies d2u by d theta 2, that will be equal to your what? U tan square n theta plus n u sec square n theta. This is the thing which you get. So suppose this is what? This is suppose your equation number 2. Suppose we know that differential equation of central orbit What is the differential equation of central orbit? We know that we know that that the differential equation of central orbit, the differential equation of central orbit is d2u by d theta 2 plus u is equal to f divided by h square u square. This is the differential equation of central orbit. Okay, so that implies what? Differential equation of central orbit is like this. So that in turn implies that your u 10 to the power minus 2, no, not minus 2, sorry. Okay, that will be what? d2u by d theta 2. In place of that you will substitute from equation 2. Okay, from 2, what do you substitute from 2? From 2, the value of d2u by d theta 2, this value, this particular value, just substitute in this equation, in this particular equation. So after you make that substitution, what do you get? 10 square n theta, okay, plus nu sec square n theta, plus nu sec square n theta, okay, plus u is equal to f by h square u square is equal to f divided by h square u square. Okay, this is the thing which you get. Then what do you get? u 10 square n theta plus u plus nu sec square n theta is equal to f divided by h square by u square. Okay, then what will happen? Take u common. So after you take u common, what do you get? 10 square n theta plus 1, okay, plus nu sec square n theta plus nu sec square n theta is equal to f divided by h square u square. What do you get? 1 plus 10 square theta is equal to sec square theta plus nu sec square n theta. Okay, this is also n theta, and from here you have f divided by h square by u square. So from here you take u sec square n theta as the common factor, okay, and multiplication n plus 1, right, is equal to f divided by h square u square. So that implies what in turn? That will imply n plus 1 multiplied by u sec square n theta, u sec square n theta, okay, is equal to f divided by h square u square. Okay, so that implies that u n plus 1, just a second, this is the final form. Then sec square n theta, what is the value of sec square n theta? Now let us go to equation number A. Have a look at this and let's go to equation number A. This is your equation number A to the power n. So from here what do you get? From here you can clearly see this thing, that sec n theta will be equal to your a to the power n u to the power n. Okay, so substitute from equation A, substitute over here from equation A. So u n plus 1, that implies u a plus 1 a to the power n u to the power n, okay, is equal to f divided by h square by u square, h square u square. So that implies what? That implies, oh sorry, sec square is there, right? What we have got in equation A? In equation A we have got a sec n theta. Okay, so we will have square over here. Okay, so after you just open the bracket, a to the power 2n u to the power 2n is equal to f divided by h square u square. That implies a to the power 2n u to the power 2n plus 1 into n plus 1 into n plus 1, just a second, n plus 1 is equal to f divided by, just a second friend, f divided by h square u square. So from here what do you get? From here you will get f equal to h square u square from here multiplied by a to the power 2n u to the power 2n plus 1 n plus 1 into n plus 1. So that implies in turn f is equal to your h square into e to the power 2n into u to the power 2n plus 3 into n plus 1, right? So you got, now rearranging the terms, what do you get after the rearrangement of the terms? After rearranging a to the power 2n, let's write properly, okay? A to the power 2n right over here, and 1 plus n like this, u to the power 2n plus 3 over here, and h square over here. Okay, now you know this very well, that u equal to 1 by r, right? So you will rewrite this f equal to, because u equal to 1 by r, so you will rewrite this a to the power 2n into 1 plus n 1 by r, so 1 by r to the power 2n plus 3. Okay, into h square, right? So you finally got f equal to h square 1 plus n a to the power 2n divided by r to the power 2n plus 3. That implies that f is inversely proportional to your r to the power 2n plus 3. Hence f is inversely proportional to, okay, so you can write from here finally, hence f is inversely proportional to 2n plus third power of the distance from the pole, Now clearly when you substitute, now you have to also evaluate the law of force for r square is equal to a square cos 2 theta, okay, for n equal to 2. So when you put n equal to 2 over here, you will get the corresponding term, okay. So I give you this part as homework. Which part? I will give you this part as homework. Also evaluate this particular part, this complete part is your homework, okay. So put n equal to 2 simply. But when n will be equal to 1, it is a special case. Special case of circle, okay. So let's see another question now. That is from Civil Services Exam 2001, CSC 2001, UPSC 2001. The question is like this: a particle describes the cardioid r equal to a 1 plus cos theta under the central force to the pole. Find the law of force. Find the law of force. The particle describes a cardioid r equal to a into 1 plus cos theta under the central force to the pole. Find the law of force. You have to basically find out the law of force, okay. So let's start this. It is given to us. Given is what? Given thing is r is equal to, similar fashion you will have to solve a into 1 plus cos theta. This is suppose your equation number 1. That implies what? Okay, that implies what? R by a is equal to what? 1 plus cos n theta. That implies what? Sorry, not this step. Erase this, okay, cut it down. U equal to 1 by r, right? U equal to 1 by r. As u equal to 1 by r, so it will become a equal to 1u 1 plus cos theta. Okay, this is the thing. Now au, that implies au 1 plus cos theta is equal to your what? 1. Okay, taking log on both the sides. Taking log on both the sides. Taking log on both the sides. Both the side, if you take log, then what do you get? Log a plus log u plus log 1 plus cos theta is equal to 0, right? Now log a and log u will yield you, so this is the thing which you get, because log 1 is 0, so right hand side will be 0. So differentiate with respect to theta. Now log a is a constant over here, okay, so differentiate. A is a constant but u is not a constant, okay, differentiate with respect to theta, then what do you get? Okay, differentiate this particular thing with respect to theta, so d by d theta of what? Log a plus d by d theta of what? Log u, and d by d theta of what? Plus d by d theta of what? Log 1 plus cos theta. D by d theta of log 1 plus cos theta. Okay. So this whole thing is equal to your 0. So clearly from here, this will be 0. First term will be 0. What will be your second term? Second term will be your 1 over u du by d theta. Okay. Plus what will happen? 1 over 1 plus cos theta. 1 over 1 plus cos theta, and du by d theta of 1 plus log of 1 plus cos theta, right? That will be equal to your 0. So from here, 1 over u du by d theta plus 1 over 1 plus cos theta. Du by d theta will be cos minus sin theta. Okay, that is equal to your 0. Okay, so from here, what do you get? The value of du by d theta. That implies 1 over u du by d theta. That is your clearly equal to sin theta divided by 1 plus So from here du by d theta will be your what, u times of sine theta divided by 1 plus cos theta, right? Now the value of u you know very well. What is the value of u? U equal to, so from this particular equation you have got, we have already got u equal to 1 over a into 1 plus cos theta, right? We have this. So just put this value over here. So when you put that value over there, what do you get? That implies du by d theta, okay, is equal to 1 over a 1 plus cos theta, okay, into sin theta divided by 1 plus cos. So what is the value you get from here? That implies du by d theta is equal to sin theta divided by a 1 plus cos theta square, okay. This is the thing which you get. Then what will you get from here? From here you will get du by d theta, okay. So sin theta can be written as sin theta by 2 times cos theta by 2. Then 1 plus cos over here, a into 1, what will it be? Plus cos square theta by 2 minus sin square theta by 2, okay. Now this whole square, so that comes out to be again 2 sin theta by 2 into cos theta by 2 divided by a 2 cos square theta by 2 whole square, right? Now the thing which when you simplify this, you will get eventually, what do you get eventually? When you simplify this further, you will get 1 over 2a sec square theta by 2 tan theta by 2. This is the thing which you get. So du by d theta value has come out to be like this, okay. Now again differentiate with respect to theta once again, okay. Now again differentiate with respect to theta. What do you get? So you have du by d theta, the value of du by d theta, again you are differentiating with respect to theta. So d by d theta of what? This stuff, 1 over 2a sec square theta by 2 tan theta by 2. Okay. So 1 over 2a will come out of here. You will get dy d theta sec square theta by 2 tan theta by 2. Okay, so just apply the product rule. You will when you apply the product rule, you get something of this kind. Therefore your d2u by d theta 2 comes out to be, it comes out to be what, 1 over 2a 2 sec theta by 2 sec theta by 2 tan theta by 2 1 by 2 tan theta by 2 plus sec square theta by 2 sec square theta by 2 1 by 2. Okay, therefore d2u by d theta 2 is equal to 1 over 2a 1 over 2a sec square theta by 2 tan square theta by 2 plus 1 by 2 sec power 4 theta by 2. Now we know that the differential equation of the central orbit is, we know that the differential equation of the central orbit is d2u by d theta 2 plus u is equal to f divided by h square u square. Okay, so what do you get from here? What do you get from here? So your expression will turn out to be, if you look properly, then your expression will become something like this. Plus 1 by 2 sec power 4 theta by 2 plus 2 cos square theta by 2 is equal to f by h square u square. Okay, sec square theta by 2 by 2a will come and tan square theta by 2 plus half sec square theta by 2 plus 1 will come. So 1 plus tan square theta by 2 will become sec square theta by 2. So that's equal to sec square theta by 2 divided by 2a, okay, into sec square theta by 2 plus half sec square theta by, okay. So that implies in turn that implies that f by h square u square is equal to 1 over 2a sec square theta by 2 3 by 2 sec square theta by 2, which is equal to 3 by 4a sec square theta by 2 whole square, okay. Then what will happen? It will become 3 by a into 1 by 2 cos square theta by 2 whole square, which is equal to 3 by a into 1 over 1 plus cos theta whole square, okay. Then that becomes equal to 3 by a into 1 over r by a whole square, because this 1 plus cos theta is what? 1 plus cos theta is r by a from equation 1, right, which is equal to 3a by, just have a look at the notebook, look at the equation number 1. So by equation 1, right, we must have written 1 by 1 plus cos theta will come out to be r by a from equation 1. Where is our equation 1? Where is our equation 1? This is your equation number 1. This is your equation number 1. R equal to a, so 1 by 1 plus cos theta will be equal to r by a, right? So it will become r by a. So by equation 1 you got this 3a by r square. So f comes out to be what? So from here f equal to, that implies f is equal to 3a by r square into h square u square. That implies f equal to 3a h square divided by r to the power 4. That implies f is inversely proportional to your r to the power 4, okay. So this is the whole thing which you get from here, okay. So in this way you can do this. Now some homework questions. So homework, all are similar question only. let's not go into that homework. Okay, so thank you very much. We are done with part 3. Now we will go towards part 4. Okay, we will go towards the fourth part. So f is inversely proportional, f is inversely proportional to r to the power 4. Yes, f is inversely proportional to r to the power 4. This is the thing which you get from here.